Before we go any further, I want to show you a very key concept to understand where we're going to be going next. Anytime you have the same numerator as the denominator, that means you have a whole thing. In other words, if I have a pizza that's cut into 2 slices, and I'm talking about both of them, that's 2 over 2. That's the whole pizza. If I have a pizza where it's 3 slices, 3 equal slices, let's just pretend those were equal, and I'm talking about all 3 of them, well, then I have the whole pizza. So you can imagine a 1,000,000 sliced pizza, and if you have all 1,000,000 slices, you still have 1 pizza. So that's a key piece of understanding before we go any further. If you don't get that, you might want to re-watch this section just so you can understand that when we have a denominator that tells us how many slices or pieces we have, if the numerator is the same as that, that means we have the whole thing. Now, here we're going to talk about how to find equivalent fractions without doing that big rectangular array or doing a bunch of drawings. Drawings can be very effective, and as we've seen, they can really help you understand. And I strongly urge students to practice with the drawings until this makes sense. The only limitation that drawings have is that they're limited by the fact that they need to be to scale. As well, if you're drawing diagrams for every single question, it's going to take you quite a bit longer. So there are actually ways of shortening your workload, and I find them to be just as, if not more, effective. So in order to find an equivalent fraction for something, all we need to do is multiply the numerator and the denominator by the same amount. The reason we can do this is because, as we said, for example, 2 over 2 is the same as saying 1. So anytime you multiply something by 1, you get the same number. So when I do this, when I multiply 3 over 8 by 2 over 2, what I'm going to get is 6 over 16. You multiply your numerators together, you multiply your denominators together. This isn't the most common way of showing this operation in grade 6. This is a little bit higher level because we don't get into multiplying fractions, but I think it's really critical that we understand why we can do this. If we don't understand why we can do something in math, a lot of the time it can lead to additional confusion. So I want to explain why exactly we can multiply by 2 over 2 and still get an equivalent value. Similarly, if I want to multiply 2 over 6 by 5 over 5, what I will get is an equivalent fraction. The equivalent fraction will have a denominator of 6 times 5, or 30. And the numerator will be the same as 2 times 5, which is 10. So we can see right now, since this is equal to 1, we are not actually changing the amount of the value of this fraction. We're just changing the number of pieces the whole thing is divided into. Similarly, our original thing here was divided into 6 pieces. Now it's just divided into 30 pieces, but because we multiply by 5 over 5, we haven't changed the relationship between the numerator and the denominator. Okay? That is similar to this, and I'll just quickly draw this to make it a little bit more clear. So if I originally have something divided into 6 equal pieces, okay, and I have 2 of them colored in. Okay, what I'm doing when I do this is I'm just carving this up with the 5 equally sized rows. Okay, so now I have 30 pieces in all, which is my denominator, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are colored. So I haven't changed the amount of coloring I've done, I've just changed the number of slices there are. And we will pause for a moment. So as I mentioned before, in grade 6 we don't normally multiply fractions. I was just explaining exactly why you could do that. In grade 6, we usually do it a little bit like this, and it's a little bit easier for students to, I guess, visualize. We set it up similar to that, and we can make these little arrows. And so if we multiply our denominator by, say, 3, then 5 times 3 is 15. Whatever we multiply our denominator by, we need to multiply our numerator by. Again, that's that whole 3 over 3 piece. And we get 9/15. So that's how we normally represent it in grade 6. Either way is fine. If you want to do it like this, 3 over 5 times 3 over 3, you're certainly more than welcome to. Certainly more than welcome to do that if that makes more sense to you, but either way is absolutely fine. Sometimes when we are doing equivalent fractions, we're starting out with a bigger fraction and we might want to bring it down to what's called lowest terms. So if we look at this fraction, 4, oops, where are we there? Okay, great. 4 16ths. Okay, so neither of those digits are odd, so that means 2 will divide evenly into both of those numbers. So just like we can multiply by the same amount, we can divide the numerator and denominator by the same amount. So since I know 2 will go into both of these evenly, I'm going to divide the top by 2, which will give me 2. And if I divide 16 by 2, I will get 8. Okay, so 4/16 is also equivalent to 2/8. Similarly, 2 is divisible by 2, as is 8. And so when I divide 2 by 2, I get 1. When I divide 8 by 2, I get 4. Now, we're at a stage where there is no number that will go into both 1 and 4 evenly other than 1. Obviously, when you divide by 1, you get the number itself. So this is the lowest terms expression of this fraction. Okay? It's really useful to go into lowest terms because once you go into lowest terms, you can just start listing off all the different equivalent fractions. So if you multiply 1 over 4 by 2 over 2, you get 2 over 8. If you multiply 1 over 4 by 3 over 3, actually I'll just draw my little arrows here. Okay, if you multiply 1/4 by 3 over 3, you'll get 3/12. Okay, and you can just keep going. 4 over 4, 5 over 5, 5 over 5, 6 over 6, etc. And so you can, if you need to, you can make a big list. 1/4, 2/8, 3/12, 4/16, 5/20, etc. You'll notice that the numerator is going up by 1 each time here. The denominator is going up by 4 each time here. So you can also look for patterns. If I was doing 2/3, it would also be the same. If I multiply by 2 over 2, I'd have 4/6. If I multiply by 3 over 3, I'd have 6/9. So you'll notice that in this one, we're going up by 2's on the numerator and by 3's on the denominator. So I can go 8/12, 10/15, and so on. I hope this has been helpful. Please feel free to go back and review if you need to. Again, the reason why we can get an equivalent fraction when we multiply the numerator and the denominator by the same amount is because when I write, for example, 5 over 5 or 7 over 7 or any number over any number, that's always going to equal 1. It's always going to equal 1 because any number divided by itself is 1. So that will allow me to go, what is 7/8 times 7 over 7. Okay, 7 sevens are 49. 8 sevens are 56. So I know that 49/56 are equivalent to 7/8. I hope this has been helpful. Have a great day, and thanks for watching this extra help from Mr. A.